In this chapter, we would apply the necessary optimization operations on the code which we wrote for the deformer in the previous video. And before we apply the optimization operations, we would have to understand a couple of things. The deformers are very computation heavy nodes, and we want to try to optimize each and every possible instruction given in the deformer. And we know that the compute function of every node is a core of the node. It's a brain of the node, and all the computations are applied in that compute function. One of the other functions of a compute function is to ensure that the data of the plug is updated or not. In other words, if the plug is clean or dirty, and if the plug is dirty, then the dependency graph will be evaluated. The evaluation would occur on the complete dependency graph. And the point where this evaluation occurs is when we get, or when we read the value as input value from a data block. So consider this as a dependency graph. So this is our dependency graph, and this is our node where a compute function will be called. So the point where we would read the value as input from data block. So we know that the data block is provided to each compute function. So whenever we would use a command m data block dot input value, it would check if the plug is clean or dirty. And if the plug is dirty, it would start evaluating the dependency graph. And the complete dependency graph would be evaluated, and when we would have our clean value here, when our clean values will be returned, it would start performing the computation. So as we said, the compute function ensures that the data of the plug is updated or not, because we want to use the clean plug or the updated value for performing the computation. We don't want to perform any computation on the incorrect data. So this is one of the functions of the compute function of any node. But in our case, we are getting the compute function, and that provided compute function is then later on calling the deform function. So to prevent the recomputation of the mesh or the reevaluation of the complete dependency graph, we can avoid using the input values here, because this computation has already been performed in the compute function, which is right above it. So what we are going to do is we are going to change input as output. So we will replace input with output. So we are using data block dot output array value and data handle input array dot output value. So there are two places we would also add array data handle dot input array value. So we have replaced those with output array value and output value. Now we are going to save it, and I would save it in C drive, plugins, Ripple Deformer optimized. Now I will go back to Maya and I will try to use the same script which we just saved. So first I will import maya.cmds as cmds.load plugin C drive plugin and Ripple Deformer underscore optimized. So I would first try to load that, and I will just check the name, Ripple Deformer underscore optimized .py. Loaded, that has been loaded, and cmds.deformer type Ripple Deformer. And I will, before executing that, I would create a sphere and execute that. So that worked fine without any error, and we have the same functionality, and you would not see a drastic effect here because it's a single mesh and it's a 20 by 20 subdivisions. But if we are applying this plugin or this deformer on multiple meshes and they have thousands of vertices, then you would start noticing this optimization effect. So that was the necessary change we had to apply on our deform function. And then there is one more thing which we can do, is instead of applying the new position of the vertex every time, we can set all the positions at once, which would be better than applying a new position of each vertex one by one. So for applying the new position to all the vertices, we are going to use geo iterator dot set all positions, and then we will provide an array of the positions. So we will create an array here, which is point array, which will store the positions of mesh vertices, which is open Maya dot point array, and every time we would append the new position to this array. So point array mesh word dot append, and we want to append point position, and later on when we are done appending all the positions, we will use this to set all the positions of the vertices at once. So save it and go back to Maya to see our changes. So I have saved the file. I will go back to Maya. I will create a new scene. I would unload and load the plugin. Unload plugin, load plugin, create a sphere, and apply that deformer. So that deformer has been applied without any error. And we can see the same effect by this, and this code is a lot more optimized than our previous code. So these are the necessary steps which we have to follow when we will write a deform function inside a deformer. Some people tend to use the compute function, and then they don't have to worry about all this optimization, because they would have to write that evaluation or the input array value function somewhere. So that was a review over the optimization of our deformer node, and that's it. Thank you so much for watching the video.